This code is used to find your flight path angle by using linear interpolation and entering your data points along with your coefficient of lift. So the first thing I did was declare the two data points, which is your first path angle, the larger one, and also the smaller one, along with the corresponding coefficient of lift. For example, I declared the largest flight path angle has path x underscore 1 right here, and also declared its corresponding coefficient of lift, which is COEFY underscore 1 in the second part. The same thing goes for path x underscore 2 and COEFY underscore 2, which are the smaller, which is for the smaller flight path angle. So I also declared your coefficient of lift that you will enter into the code has COEFY underscore 3. To the next thing I did was use the printf so that the user will be able to enter the flight path angle and the corresponding angle, so that they will use it to find their flight path angle. So I use the scanf also so that the user will be able to enter their various values for it. I use it for the smaller one and also for the larger one. And also have the same thing going for your coefficient of lift. So the next thing I did after laying out the platform for the user to enter his or her number, then next I did was to use the formula to find linear interpolation for the flight path angle. So that's the solution the formula right here, which is used for it. And then I use the printf function to write your flight path angle is in degrees, and also use the declared path x underscore 3. And I'm going to compile it and show you that it actually works. So we have the code running, and we have the first line of code, which is reading right here on the printf. Right here. So after the code runs, it's the printf, which the sentence was written on the printf is right here. So then I enter the flight path angle that is in my on my table. Just put a random number, like say 7, and then I enter the coefficient of it, and I'll say put a number, let me say 2, and then I put in. Then it goes to the next line of code, which is the next line for the smaller flight path angle and the corresponding coefficient. So I put smaller flight path angle, I put 6, and I'll just put 1 as a corresponding one. So the next one should go to enter your coefficient of lift, which I'm just gonna put, let me say 3 or 1.5. So the answer should be, if I click enter, the answer should be around the 6.5 or something around that. And yeah, a 6.5 degrees angle. So that's it.